Hi, this is Paul Miller with the Colorado Basin River Forecast Center. On today's webinar, we're going to discuss March's water supply forecast and forecasted water supply conditions throughout the Upper Colorado and Lower Colorado River Basin regions. Just to give you a quick overview of today's presentation, we're going to talk about our new Upper Colorado Situational Awareness Decision Support Tool. It's a new website that you might have heard Brenda talk about if you watched our webinar from last month. But we want to go into it in a little bit more detail and advertise it again, just to make sure we're reaching a nice broad audience out there. We're also going to talk about the recent February weather conditions and impacts. It was a very dry month, and you might be interested in how those very dry conditions impacted our water supply forecast. And then we're going to talk a lot about the hydroclimatology throughout the region, specifically about the snowpack, the soil moisture, and we'll also talk about that El Niño event that's been occurring, though we haven't really seen the impacts that we might have expected from the El Niño event. Then we'll give you a big overview of the March water supply forecast, the upcoming weather and climate outlook, and then we'll talk about the upcoming water supply briefing schedule if you're interested in any other webinars that we're putting on, and we'll give you our contact information, and we'll close it out from there. So like I said, first we're going to give a quick shout out to our new Upper Colorado Situational Awareness page. This is in response to a lot of questions that we've had in the past where people have said, I love your website, I love the data that you have, but I want to see it all in one spot, and I want to be able to go to one page and see everything I want to see. Well, this is our attempt to do that. You can see here that we've got a large combination of different information here, different maps, different tables, pie charts. We'll talk all about that. But first, you can get to it by going to the web address that you can see in the bottom right corner here. I'll try and circle it with my mouse here. Or if you go to our homepage, www.cbrfc.noaa.gov, and under water supply, click on the link that says Upper Colorado Situational Awareness. It'll take you right here. So just to summarize, we've got a lot of maps on this page. You can see soil moisture conditions as represented in our model, snow conditions also as represented in our model, water year precipitation, and also month-to-date precipitation. This was a question that people would ask us all the time about what did the current storm do to the month's precipitation amount? How far are we in the month towards reaching average? Are we above average? Are we below average in the month? This is a great map to take a look at. You'll notice that the maps don't show the entire area right off the bat. They're trimmed to show just the areas that we feel contribute significantly to Colorado River Basin stream flow. So those are the ones we think contribute significantly. You can get to maps that show the entire basin colored out through our homepage and through other experiences. But for just that snapshot, for just seeing the information that you really want to see to assess water supply conditions, particularly in the Upper Colorado River Basin area, this is the areas that you want to focus in on. We also have some tables. People were saying that, hey, I have to click here, I have to click there to get these numbers for my reports. Well, hopefully this table kind of summarizes the most pertinent information that you might have for those reports. This page is a work in progress. If there's other numbers or other information or other things that you'd like to see, please feel free to give us a call, shoot us an email. We'd love to hear how you're using this page, what could also be useful on this page. Just let us know. One of my favorites of this situational awareness page are the pie charts. I think this is a really cool thing because it's something new that we haven't shown in the past. And what we're showing here is the average streamflow contribution throughout the Upper Colorado River Basin from some of the major sub-basin areas. So you can look on the left side. That shows the average contribution each year to the April through July runoff from sub-basins in the area. So you can see the San Juan, the Green River Basin. The Upper Colorado headwaters are kind of represented by the Colorado at Cameo, the Gunnison River Basin. And then we've got all the other side inflows and stuff that tend to come in that play a more minor role. You can see in March that we're forecasting a slightly different contribution this year, but relatively about the same proportions. You can see we're getting a little bit less from the green, or at least forecasting a little bit less from the green this year, and a little bit more from the San Juan, the headwaters, and the Gunnison River Basin, as well as those other side inflows. Below the pie charts, you'll see a bar chart just indicating where the current forecast is and how it relates to the historical average and the historical maxes and mins. And we also show our min and max probable forecasts on there, so you can see the range of uncertainty in our forecast. There's also a box with links to additional information. These are some of our most popular products and tabular information related to those products. We also have a link to the Bureau of Reclamation's 24-month study that a lot of our stakeholders might be interested in. So that's it for the Upper Colorado Situational Awareness page. Again, it's a work in progress. We're really happy with the page so far, but we're still building on it, and we've already begun to implement some improvements that we've received from you all, and we will continue to try and improve the page so that you can get that quick snapshot of information. Really interesting month. What you're seeing here on the screen is a map showing the jet stream over the continental U.S. And what you're seeing here is this trough that came through at the beginning of February, right when we were making our precipitation to the area. A really great way to start the month, usually. A lot of precipitation, had all a nice month for water supply and precipitation in general. But after that first initial storm, this ridge formed over the Colorado River Basin area and diverted all that moisture around us. So we actually ended up with a very warm, historically dry February in the Colorado River Basin, despite that initial storm at the beginning of the month. So again, we don't want to see these ridges. This just means dry, warm conditions. Kind of showing that in map form here, our monthly precip for the region was pretty low. Very dry conditions throughout the region. You can see in the very northern part of the upper green where that ridge was kind of going around the northernmost portion of our area of responsibility. This little portion here benefited a little bit from the moisture that was brought in from that ridge, but for the most part, the Colorado River Basin experienced a very dry, very warm month. You can see the departure from the maximum temperature averages here on the right. Generally, we were 5 to 9 degrees above average throughout the basin. This resulted in early snowmelt in some areas. Kind of zooming in on those significant areas in the upper Colorado River Basin. When we're looking at the monthly precip here, again, you can see that when we zoom into those significant areas, very, very dry conditions, except for maybe the very northernmost portion of the Green River Basin, and those maximum temperatures, very warm, led to a lot of early snowmelt, particularly at low elevation sites. Taking a look at our water year precipitation for the season, we're still hovering, near to slightly below average conditions. This is a bit different than in February. In February, we were closer to 110% of average snowpack in a lot of areas. We were off to an okay start for the water year, but the very, very dry February has pushed a lot of these departures down to near average or below average, particularly in the headwaters region and the northern most portion of the CBRFC region. And you can kind of see that as we've zoomed in here on the right to those significantly contributing areas. A lot of these areas are closer to the 90 percentile range as opposed to near average, so slightly below average conditions after that very dry February. Taking a look at the SNOTEL stations in our area, you can see a lot of the SNOTEL stations are reflecting what we're seeing in our model, near to slightly below average conditions for the most part. Brenda Alcorn in our office, she went through and looked at the precipitation measurements from the SNOTEL sensors throughout the upper Colorado River Basin. And you can see at this table on the right here the number of sites in each subbasin that were reporting February precip among the top 5 driest in their historical record. The historical record for a lot of these sites goes back about 35 years or so. So just so you know what kind of length of history here that we're working with. But you can see the Green River Basin, 11 of the sites were reporting February precip in the top 5 driest on record, with 3 of them actually being the driest February on record. Yampa, 5 of their sites were showing the driest February on record. And in the San Juan, lots of sites showing a very dry February, 2 of them indicating the driest February on record down there. I just kind of wanted to highlight some of the behavior here at some of these sites. Looking over in the Green River Basin at the Huinta SNOTEL site, you can see we're basically following along the median line, slightly above normal conditions there. But again, that site showed the driest February on record. Switching over to the Yampa River Basin and the headwaters regions, looking over at the Sandstone Reservoir, you can see over here how, heading towards January, we were following pretty close to normal for the most part, and then February hit, and that snowpack accumulation basically stagnated right there. We've just seen this flat trend that came from last month. Similar situation down here at Park Cone. This was the second driest February on record there. Again, another flat snowpack accumulation signal there. And at Red Mountain Pass in the Gunnison River Basin, again, flat. We were trending pretty close to normal, and then that snowpack accumulation just basically stopped in February. Looking at how that snow is represented in our hydrologic model and just how it's changed over the past month. The figure on the right shows February 1st conditions, and you can see, like I said earlier, we were hovering around that 110% of average snowpack in many of the headwaters regions, particularly in west central Colorado, the headwaters of the Gunnison, that area. So things were looking pretty good. And then after February, now looking at March 1st conditions, you can see just how much we've dried out. We've gone from a lot of those 110% of average and higher down to 90%, 100% of average, just about. So again, very dry conditions have led to a much lower snowpack heading into this month. Just wanted to recap our soil moisture. We spend a lot of time talking about snowpack because that is one of the drivers that we look at when we're making our water supply forecast. But stream flow is not a one-to-one correlation from snowpack conditions. You can have 2 separate years, both with 100% average snowpack, and one year you might get below average stream flow, and one year you might get above average stream flow. So there's a lot of different hydroclimatic factors that go into developing a streamflow forecast. It's not just the snow on the ground. And another one of those primary drivers is soil moisture. When we have drier soils, we tend to experience less efficient runoff. And what you're seeing here is our soil moisture representation from this fall before the snowpack began to accumulate. And you can see very dry conditions throughout the entire CBRFC region. But in particular, kind of looking over into central Colorado and the Colorado headwaters and the Gunnison and the San Juan, especially the headwaters of the San Juan, very, very dry conditions. So to us, that indicates that we're going to need some very favorable snowpack conditions just to get to an average runoff. So when that snow begins to melt, we're going to start losing a lot of the runoff to replenishing the soil moisture tanks or replenishing the soil moisture states in the area. And that's just one reason why we're not seeing, even though we're seeing 90%, 100% of average snowpack in these areas, we might see forecasts that are closer to 80% of average, 85% of average, that sort of thing. This is a new graphic we have, and I don't want to get too crazy with it, but we're just showing here inches to saturation as our model sees things. And what you'll notice here is some areas show up on one side and some areas don't. But I think the message to take away here is that you can see at the beginning of February, still very dry conditions. Snow hadn't begun to melt. And as we've come into March and we've seen snow melt at the lower elevation areas, we see these areas where our soils are becoming more saturated. That's not necessarily a good thing for our water supply forecast. This is just an indication that we're seeing some activity here that's saturating the soil. And in this particular case, that activity is early snow melt, particularly at lower elevations. So again, we're seeing some saturated soils here. Now, if we were to get a rain event or an additional snowpack event over these areas, maybe we could see some additional runoff. But right now, they're mostly indicating that we're seeing this early snow melt in February due to that really warm month, and it's saturating those soils a bit prematurely. Okay, so now let's talk about El Nino. And you've probably heard all kinds of things about this El Nino. It's gotten a lot of media attention. There's been a lot of anticipation that it would bring increased precipitation to the Colorado River Basin, particularly in the south. And so far, we haven't seen those impacts that are typically associated with El Nino. And before I get too far into this, I just want to put in a plug for climate.gov's ENSO blog. If you just Google ENSO blog on Google, I think it's like the first thing that pops up, but it's on climate.gov's website. And there's some really great articles that are very accessible, present a lot of great information, and some really great graphics, and they explain it in a fun and interesting way. So just want to plug that really quick. But anyways, what you'll see is a couple graphics that I took from that ENSO blog. And, we've gotten some questions on, is this the strongest El Nino ever? Well, it's definitely going to be among the strongest. You can see based on the indices that we derive from sea surface temperatures, this one is definitely on the order of strength as the very strong El Nino event that we experienced in 1997 and 98. But you can see just because of those bands of uncertainty in the instrumentation and the records there, we can't definitively say this is the strongest, but it's definitely going down as one of the strongest on record. Just showing some of the differences, though, between those two events. So you can see the 1997-98 event here on the left. Lots of precipitation activity along the equatorial Pacific. And with this particular one, we're still seeing some activity around the equatorial Pacific, but it's not extending as far east as we saw back in 97-98. So part of the reason why we haven't seen that increased precipitation in the south is because a lot of this activity just isn't happening as close to us this year. Kind of, again, looking at why this strong El Nino event hasn't really played out like we would have expected, and how unique it is that you can see sort of the average jet stream here kind of represented during a El Nino winter, and you can see this jet stream, it's a little bit south. It's kind of right at the edge of it is right at the border of United States and Mexico. But the jet stream during this El Nino winter, you can see it's been shifted north, and that's resulted in a lot of that precip that the Pacific Northwest and Northern California has seen, which typically isn't associated with an El Nino event, particularly a strong El Nino event. And some of the initial findings coming out lately is that a positive Arctic oscillation probably helped to bring this jet stream more northward. And so for the Pacific Northwest and for Northern California, that's meant quite a bit of rain. But for us, it's meant that we've missed out, unfortunately, on some of the beneficial precipitation, as those storms seem to just sort of go around the CBRFC region. This is just a plot showing during an average ENSO event. You can see we tend to expect more precip here in the lower Colorado River Basin, mostly in southern Arizona. Things tend to be drier in the Pacific Northwest. But with this particular El Nino event, very wet conditions in the Pacific Northwest, and not only in the lower Colorado River Basin, but throughout the CBRFC region, basically average precip conditions for the year. So just kind of looking at where we stand today with El Nino, it's cooling and weakening the sea surface temperatures along the equatorial Pacific. And what our models are currently showing is that by late spring, we'll probably cool down back into neutral conditions. And there's a possibility that we might transition into La Nina conditions by late next fall. You can see sort of the big spread of the models here going out into next year, or towards the end of this year. And one thing I just wanted to note is that we're coming up on this time here where the models don't perform as well as they do during other times of the year. And that's because during spring, they just don't capture the dynamics of the atmosphere and the ocean as well as they do in other times of the year. So there's a lot of uncertainty during what we call the spring predictability barrier. Just wanted to illustrate how precip has looked at different areas over the CBRFC region. The Colorado River at Grand Junction, what you'll see is the observed accumulated precipitation in this dark blue line here that I'm tracing with my mouse, and how it compares to the average during an ENSO year. These lighter blue lines are other ENSO events, and the gray lines are all other years compared to this average, which is like a dark gray line. So anyways, in Grand Junction, we're trending above the average ENSO year so far, but you can see things have flattened out quite a bit, particularly during that dry February. You can see basically a steady increase from the beginning of the water year in October through January, and then we hit February and flat. Lander, Wyoming is just outside of our region, but it's kind of the closest one where we have a long-term record that we can do this kind of analysis with. It's just to the east of the eastern edge of the Green River Basin, of the northeastern edge. You can see it's trending pretty closely to an average ENSO year. We'll see if it takes the same kind of increase that other years have done in the past. But again, you can see that flat signal that we just had in February. Down south in Tucson, Arizona, you can see we're basically trending pretty close to that ENSO average, maybe a bit below now. Again, February, just dry. And over in Las Vegas, you can see we had a really great start to the water year. A lot of winter storms rolled through the area. But basically since November, December, things have been relatively calm over there. Great. So now we'll just talk about our water supply forecasts for this month. And I think the big takeaway is that our water supply forecasts have decreased since February. Looking here at the beginning of March, and just again beating a dead horse here, but that very dry February decreased forecast throughout the entire upper Colorado River Basin region. So you can see a lot of decreases here on the order of about 100,000 acre feet. The Lake Powell forecast with a decrease of 1 million acre feet there, that's pretty significant. Looking down in the lower Colorado River Basin, where our forecast period is January through May, with the exception of the Little Colorado at Lyman, which is January through June, you can see we're still above average forecast in that area. That's because we're still forecasting that El Nino will have a bit of an impact on those water supply forecasts. So we're still holding out hope there. But all of these forecasts have decreased since February 1st as well. Just kind of going to run through our evolution plots here just to give a summary of what we're showing here. You'll see the official forecast for March. It'll be this last red line here on your right. You can see the past official forecast in February and January to your left. You can see the daily guidance from our model. It's these blue lines here that are showing our daily water supply forecast as just issued by the raw model guidance. And then you'll see our most probable forecast here in the center, that 50th percentile that we typically report. And then we're also reporting the 10% exceedance, the 30% exceedance, 70 and 90% exceedances as well. So for Flaming Gorge, we're forecasting 660,000 acre feet. That's this red box right here. And that's about 67% of the average between 1981 and 2010. Going down to the Wolford Mountain Reservoir, you'll notice a 9% decrease since February 1st. I tried to highlight just how that daily model guidance just showed a steady decline throughout February, as we just didn't see any precipitation impacts throughout the month. Yampa Deerlodge, 14% decrease since February 1st. The Gunnison at Blue Mesa, a 9% decrease in forecasted conditions since February 1st, particularly in the East River Basin. Snow conditions there in particular have declined quite a bit. In the San Juan River Basin, dry conditions were expected, and they were unfortunately realized. One thing I wanted to point out, though, is that when we were making these forecasts at the beginning of the month, due to that really busy storm event that we had, the raw model guidance really wanted us to forecast a bit higher here. And here, Greg Smith, who does the forecast for the San Juan River Basin, he didn't chase that storm event early in the month. He looked at the weather models, noticed a ridge possibly forming, and he decided to stay closer to the raw model guidance before that storm event. So it ended up being a pretty good call there. So just wanted to give a shout out there to Greg and say nice call on not chasing that storm and that model guidance there. Again, here's another example of not chasing the storm event here that happened at the beginning of the month. This is the Dolores Reservoir, the McPhee Reservoir in the Dolores River Basin, a 24% decrease, but it could have been a much larger decrease. We could have issued a forecast that could have been about 50,000 acre foot higher in February. Going down to the lower Colorado River Basin, here's the Virgin River at Virgin, Utah. And you'll see here the impact taking into account El Nino is having on our forecast. You can see the raw model guidance and the 50th percentile value along where my mouse is sliding. But you'll see our forecasts have been a bit higher as we tend to experience more precipitation during El Nino years than other years, so we're trying to account for that. Hopefully we'll see it. Thus far it hasn't shaped up as a particularly wet year. Here's the Salt River near Roosevelt. Again, you can see that effect of the El Nino signal there. We're forecasting slightly higher than model guidance, but we're still hovering close to median conditions in the Salt River. Looking at Glen Canyon Dam and Lake Powell in the Colorado River there, you can just see the effect of that really dry February. We were forecasting just below average conditions on February 1st, and just that very dry February continued decrease led to a million acre foot decrease in the forecast. We're down to 80% of average for the Colorado River at Glen Canyon Dam. So just to summarize, a historically dry February resulted in reductions across the board throughout the upper Colorado River Basin and even into the lower Colorado River Basin. We saw early melt, particularly at low elevation areas due to the warm temperature, and just didn't realize the precipitation that we typically do during an El Nino year in the lower Colorado River Basin. Snowpack conditions were generally favorable at the beginning of February, but February is so dry that now we're closer to near or below normal conditions pretty much throughout the entire upper Colorado River Basin. And El Nino conditions are weakening, and we're expected to return to neutral conditions by late spring. It's really uncertain at this point, but a lot of the models are indicating that we could develop La Nina conditions by late fall. Just taking a look at the current system of the weather, there's a current storm system coming through. It's really hammering California and the Pacific Northwest as we speak. And we're thinking some of those remnants will make its way over the Colorado River Basin in the next couple of days, but we're not expecting to see a ton of water associated with the storm, probably only a half an inch to an inch. Looking out even a little bit further with our weather models, we might have a good shot at precipitation around March 12th when we could see this trough kind of develop over Utah, and that could potentially set up an active weather pattern for the rest of the month. So we're crossing our fingers. Just looking out at the 7-day precipitation forecast, you can see the impacts of the storm on the Pacific Northwest and particularly Northern California here. Some areas expected to see over 10 inches. Where we could use it a bit more is over here in the Colorado River Basin. And you can see we're in that half inch to an inch range throughout most of the region. Just wanted to show how that storm's expected to develop a little bit here. So, the first couple days, the storm is really impacting the West Coast, not really impacting our region much. We'll start to see some windier conditions as the front moves through, and then we'll start to see precipitation probably Sunday evening, night into Monday. We'll see some stormy conditions over our area. From the Climate Prediction Center, the 30-day outlook for March is generally calling for wetter conditions, particularly in the south, and maybe warmer conditions in the Great Basin region, but generally equal chances for warmer, cooler, or normal conditions temperature-wise in our area. Just kind of looking here at the precip and temperature outlooks for the March, April, May periods and the April, May, June, July periods. You can see the impact of that ENSO event. We're still expected to see wetter conditions seasonally through June, and basically equal chances for warmer, cooler, or normal temperature conditions in our area. Here's some upcoming briefings that you might be interested in. On Monday, March 7th at 10 o'clock Mountain Time, we'll be having a Great Basin water supply briefing for those of you interested in the Great Basin area. Greg Smith will be giving that particular briefing. Ashley Nielsen in our office will be presenting on peak flows in the area on Thursday, March 10th at 11 a.m. Mountain Time. And if you're interested in any other briefings throughout the season, check out our full briefing schedule on our website. Also, we did a live demo a couple weeks ago of all the new features on our website. There's a lot of stuff to check out and look at there. Definitely take a look, and we'd like to do more of these live demos in the future. But let us know if you have any questions. Let us know if you want to see how to assess the impacts of a recent storm in your area, or assess how soil moisture is changing in your area. These are things we can do on a live webinar and just show you how to click through our website and figure out these kinds of things. So yeah, let us know. And here's all our contact information. Michelle Stokes is our hydrologist in charge. Brenda, Greg, and Ashley take care of a lot of the forecasts in the upper Colorado River Basin. Tracy Cox does the lower Colorado River Basin, and I do the forecast in the Great Basin. So again, please feel free to give us a call, email us, let us know what you're thinking, let us know if this is useful for you, and we'll talk to you next month. Thanks.